Let's keep going. More regular polygons today. And again, none that we have a formula for, so we are still going to have to break it up into triangles and multiply by how many I have. But the problem's going to be, like yesterday with the hexagon, it was a 30, 60, 90, right? Well, what happens if we got to find the area and it's not one of those special triangles? What do I need to rely on from this year? First, this is a pentagon. And I know some of us yesterday, we did the hexagon, and I showed you the area of a hexagon, and what was it, the radical 3 over 3 times s squared, whatever. And it still had some kids, I'll remember that formula instead of doing this method. All right, fine, do that, kid. That's all right. So here you go. Here you go, no problem. So you guys that are keeping track of your formulas and don't want to do the triangle method, there's your pentagon formula. Good luck, everybody. Good luck with that one, too. All right, yep, not bad at all. Yep. Square root within a square root, that's good, always good too. Yep. So go right ahead. There's your pentagon one. All right, so if you want to remember the area of a pentagon without doing my triangle method, go right ahead. All right. All right, so here we go. So it is a pentagon, so 1/2 base times height, one of the triangles times 5. All right, times 5. What was that 10 inches called again? PR, what did we call that yesterday? Let's hear our first person today. 9. What's the 10 inches again? It's a radius, correct. All right. So I didn't give you anything. You got to help me get the base and the height here. So the first thing, this is how I approach it all the time. I find the angle formed by the 2 radii. So I need your help. What is angle RP? Q here. I always start by finding, hey, what's the angle between the 2 radii? Because I know the height's going to bisect it. So how can I find this full angle here so I can bisect it? Talk to me here. 14. You do 360 divided by 5. Good. 360 divided by, take a look, the 5 congruent angles if I drew all the radii in. Yep. And that gives me 72 degrees for angle RPQ. It gets bisected. So what's the bisected angle measure then? 8. Sorry. I have 72 for the full angle. What's the bisected angle then? RPS. What do we have? 36. So hey, take a look. That's 36. Whoa. That's not 30, 60, 90. That's not 45, 45, 90. Let's start off by finding the height. PS, I'll call X. Well, what happens now if I don't have any rules? Is it still a right triangle? Guess what? I can still use that as long as it's a right triangle. And this is why I'm over here. Pythag. How many? I only have the 10 though. Right? I don't have enough info. Everyone for Pythag? That is true. I could use Pythag if I had enough information, but I don't have anything on RS to plug in. So what can I use though? Sine, cosine, tangent. All right, I can use one of those 3. So let's figure out which one I need here to find the height. My first question here, 28. What's the 10 in the diagram for right triangle PRS? Hypotenuse. The height I'm trying to find is? Okay, everyone, I got adjacent, hypotenuse. Which one of the 3 is the most acceptable one up here? 7? Cosine. Here we go. Cosine. 36 equals adjacent x over hypotenuse 10. How'd we solve these back in the day? Cross multiply when I put cosine 36 over 1. Real quick before you start typing like you're texting, are you in degree mode? Make sure you probably are. Are you in degree mode? So cosine 36, multiply that by 10. Is that going to be our area? Nope. Why did I ask that? Don't round the darn thing. All right, because that's might throw off your final area. Write it all out. I'll even do it. 8.090169944. So I'll plug that in for H. All right. How about the base now? How do I find QR? QR. Well, I can't find QR until I find RS. And then hopefully I'll be disciplined enough that when I find RS, that's not the base. I'm going to have to do what with that value at the end before I plug it in for the base. 5, so I find RS, but I'm not going to plug that into the formula until I do what with it? Multiply it by 2. All right, how can I find Y? Options. Here you go, kids. Options. How can I find different options? How can I find Y or RS? SOHCAHTOA, sine, cosine, tangent, and it just got brought up last time, but I couldn't use it, but I can now. Pythag. Just make sure you use your non-rounded answer. All right, so honestly, you could use sine, tangent, or Pythag here. Only thing you can't use cosine. So you decide what you want to use. I'm going to be a sine guy here. I'm going to do opposite over hypotenuse. Not sure where that came from, but that's about 100 plus off. So unless you want to be on strike for notes, that's fine with me. Here's what I'm getting for half of it at least. Again, that's not my base. That's not my base. That's just RS. I'm going to have to double that bad boy before I plug it in. So I'll let everybody do their thing, crunch the numbers on the calculator, and let me know what you get. Okay, when you're ready with that area, round it to the nearest tenth. Let me know. 25 when you're ready. Thank you. How about 17 when you're ready?
237.8.
You can thank your partner for that. Make sure you can actually get that, Riley, please. Thank you. Inches squared. Everyone's good? Now, I get it. The process isn't that bad, but there are simple mistakes that could be made. Not doubling RS, forgetting that. And it happens all the time. Only finding the area of one triangle and forgetting, oh yeah, there's 5 of them. Okay? Yeah, real, because you take whatever time it takes, say 5-6 minutes to find the area of the triangle. You're like, whew, exhausted. We're good, but you forget about that there's 5 of them. Oh, any questions? All right, I'm going to go hands off on the next one. Finding the area of the octagon, and I will let everyone know, yes, this is supposed to be perpendicular. I don't think there's a right angle there. You're welcome, by the way. You're welcome. What did I already just give you here? The height of one of those triangles you're going to find, yeah. All you got to do is find the base now. So you should only be doing one sine, cosine, tangent calculation here. All right, go ahead. We'll talk here in a couple minutes. All right, quick talk here. First, again, I always find the angle between the 2 radii, which in this case would have been 360 divided by 8, 45 degrees. Now, does this make this a 45, 45, 90 problem? Absolutely not. You got to bisect the thing. All right, the height is bisecting that angle, so hopefully you worked with 22.5 degrees and not 45. And you use which one of the 3 ratios with opposite and adjacent here? Which one of the 3 was I using? Oh, 28. That was so anti-climatic. Like, I was all like, I knew it was Tyler, pointed right to him, and no look pass. And
opposite end Jason's tangent.
Thank you. Could have used that about 30 seconds ago. Yes, we should have used tangent here. Tangent of 22.5 equals x over 8. Ooh, did you double it? Right? Did you double it? And that's what I plug in here for the base. After that gets doubled, multiply them all together here. Uh-oh, here we go. Come on, pressure's on. Nearest 10th. 15.
212.1.
How about 212.1? 212. This guy. Always better than everybody else. Yeah? Thanks. No issues. All right, what do you say? We end the week here. Just get nuts on this last problem. Go crazy here. Yep. Help our boy out here, Big Al. He's going to seal his deck. And oh, conveniently, his deck is a regular octagon. Go figure. All right. That's actually, there are some octagon decks out there. Let's be real. Stop, please. There has to be. There has to be. Oh, we got one in here.
Yeah. That's not. It's not. That is a test your house.
Do you like Zebo attached to your house already?
No.
I do, obviously.
You should watch it.
There's a ton of these. There you go. There you go.
All right.
Like, yeah, these are all like coming off the head a little bit.
Is that a regular octagon though?
Ooh, good question. I don't know. It's gonna have no idea what I mean anyway.
That one down there did.
Yep, there you go. All right. All good? And I should have went over, sorry, you guys that are compiling all these formulas, there's your octagon one. Okay,
That
so
one's not as bad.
hey, just make sure you keep your radical straight, right? Because didn't the hexagon have a radical yesterday too?
That was 3 radicals, 3 over 2. Besides
I was over 3.
Huh? No, it was over 2.
It was definitely over 3. Put money in
It was over 2.
over 3.
All right, so let's help him help Big Al out here. He's got to seal his deck. It's a regular octagon. Perimeter is 128. Distance from the center to any side is 19 feet. What I'm giving you there, the distance from the center to any side, what do you think I'm giving you there? The height, you're welcome. Yep, I am giving you the height is 19. Wow, and then we just keep rolling here. 1 gallon covers 125 square feet. A 5-gallon container, $98. All right, how much is Big Al spending? Whoa. I get it. We're in the area unit, so obviously I'm going to find the area. But what up there signals to you have to find the area? Because I threw perimeter in here too. So why can't I use the perimeter? Why do I need to find the area? What up there signifies this is an area problem? There's wording in there that says you're finding the area. Seal it? So that makes it area?
Yeah.
Okay, now we got to fly in here. You guys are like toddlers. Like all of a sudden some other distraction comes in here and now we're all focused on the fly. That's okay. Everyone acknowledging the fly that came into the room. We're good? We're all good. All right, this is not even, we'll just wait. Maybe the fly will come around somebody. We can get rid of it. Maybe I can open up the window maybe, and that'll be even better.
Yeah. 16 per side.
All right, maybe it'll go out.
Get him, John.
Out the door maybe. Ah, no, we came back in.
Kyle, get it.
just keep recording this. Out. Go. Oh, did we go?
Yeah.
So if anybody wants to relive that this weekend, go ahead and play the video here. Okay, just make sure you fast forward to the about the 15-minute mark. All right, back to Big Al and helping him. Back to my question, how do I know this is an area problem? Okay. Anytime your units are squared, it's an area. Okay, so that's how I know I'm going to take the area of this octagon, 1/2 BH times the 8 triangles. But lucky for us, I don't think any sine, cosine, tangent are needed, right? Why not? Well, we already said 19 was the height. How can I get to the base now without having to use sine, cosine, tangent, dividing it up? Regular. Remember what regular meant. How can I find the one side pretty quickly, or the base pretty quickly here? Talk to me. Oh, 24. Yep. 128 divided by the 8 congruent sides. 16. 16 for my base. Times by 8. All right, what is the area of Big Al's deck? 13. Yep, take your time. 1,216. That is how you say it, not a 1216. Square feet, right? Okay, so now how many gallons do I need? And this is the same problem I talked about when we did shaded regions. Some of you guys see this 125 here and you get nervous because you don't know, do I multiply or do I divide with it? Stop being nervous. Set up a proportion to use. 1 gallon, here you go, 1 gallon covers 125 square feet. Start out with the conversion, whatever they give you in the problem. Then keep the same units together. 1,216 square feet. How many gallons? Do I expect everybody to do this? No, but if you're unsure, you better be setting up a darn proportion. And then I cross multiply, and then you start seeing, oh, I actually divide the 125. It's not multiplying it. Plus, I think if you multiply, that's a heck of a lot of gallons. Let's be real here. All right, that's a heck of a lot of gallons. And speaking of real life, you can't get that amount of gallons at any store. So don't use it. Instead, how many gallons am I going to actually need here to get the job done? 10 gallons. All right, now let's get to the money part. How many containers am I going to need? Keep reading the problem. There's a lot of facts here. Keep reading. How many containers am I going to need? 13 again. 2, not 10 containers, because take a look. It's a 5-gallon container. So 10 over 5. Yep, 2 containers at $98 containers at $98 a piece. Let's finish this off. How much money is he going to spend sealing that deck? 25. Not here. Great. How about 23? Oh, wow. 2 for 2. 27. $196. There we go. All right. Let's get out of here without any work to do over the weekend. All right, 4 problems. Let's get it done. Get out of here without having to finish anything.